Yes, really, we want to evaluate the specified integrals. If you look at the three integrals here, notice that in the integrand, we have x and a y on the first one, x and a y on the second one for the integrand. Same thing for the third. But the first we're integrating with respect to y, the second with respect to x, and the third with respect to y. Just like with partial derivatives, we talked about in an earlier video, if you have a function of or an expression of several variables and you differentiate with respect to one, the others remain constant. So you treat them like numbers. Same thing with the integration. In this case, we have a y, the first one, integral with respect to y. We treat the x as a constant. So for number one, then we have, this will be equal then, integral from 0 to x. Because we're integrating with respect to y, we treat the x as a constant. So if integrate with respect to y, 2x would be 2xy. It's like if this was a 2, and you integrate with respect to y, it would be 2y. But in this case, the x is constant also, so it comes along for the ride. We get this. The next one we have y, integrate with respect to y, this would be y squared over 2. Using the same formulas. The only thing you have to remember is you treat the x here as a constant. And then the limits of integration go from y equals 0, put it there, to y equal x being a constant. And then as normal, we just plug in, evaluate this thing at x. We have an x, we have a y rather, you put an x, because it's y equal, the limits of integration are y equals 0, y equal x. So this would be 2x, and then the y is replaced by x. And this minus, replace the y by x. This would be x squared over 2. And then it's minus the value of y at 0. So that was y0 here, y0 here, so this is 0 and 0, so this would be 0 minus 0. So this then comes out to compute this would be 2x squared minus x squared over 2. Get the same denominator, so multiply here by 2 and here by 2. You get 4 over 2x squared. So this will come out to 3x squared over 2. Quantity, or 3x squared over 2. Getting the common denominator here. 4 over 2 minus 4x squared over 2 minus 1x squared over 2 gives me this. Now for the next one, you're integrating with respect to x now. So the y is a constant. So let's do it this way then. You can take this y out if you want, and then you got dx over x. So this would just be y then, natural log of absolute x. Y is a constant. And then we integrate then, limits of integration is going to be from 1 to 2y. In this case, we say the limits go, because we're integrating with respect to x, from x equal 1 to x equal to 2y. So where you have an x, you put in 2y. And then it's a minus y ln. You have an x, you put a 1. This will be a 1 here. This goes to 0 because the natural log of 1 is 0. So this gives us a y ln of absolute 2y. That's the solution to this one. So the procedure is the same. Okay, we integrate the integrand with respect to, in this case, the first one was y, the second one was x, and then we integrate this as usual, just treating the x as a constant, and then plug it in the values to get the final answer. In this case, 3x squared over 2, and for this one, y times natural log of absolute 2y. Okay, for the third one, integration is respect to y again. So the x, or x squared in this case, is a constant. Limits of integration go from y equals 0 to y equal square root of 4 minus x squared. So let's integrate then. Integrating with respect to y, so add 1 to the y there, to the exponent. This will give me a 2, and then divide by 2. And then the x squared is constant, comes along for the ride. And then the limits of integration then go from y equals 0 to y equal the square root 4 minus x squared. Again, integrating with respect to y, so y equals 0 to y equals square root of 4 minus x squared. So for the upper limit, got the x squared being constant, replace the y then by the square root 4 minus x squared. So the y is replaced by square root of 4 minus x squared, and then that's going to be squared. And then it's going to be minus this expression evaluated at 0. That is, y will be 0, so put a 0 here. 0 squared is 0. 0 times x squared is 0 divided by 2 is 0, so this gets wiped out. And this, of course, is over 2 here, from that number there. So we get an x squared, and you square this radical, eliminates the radical. We get this. Then we simplify, just multiply through here by x squared here. In the numerator, we get 4 x squared minus x squared times x squared is x to the 4th, and that's over 2. That's the answer for this one. 4x squared minus x to the 4th over 2. Now when you're working double integrals, you're integrating with more than one variable, x, and then a y. It could be triple variable, x, y, z, but you'll be doing the integration like this. You integrate with one variable, and whatever other variables are there in the integrand, those will be constant. That's the answer for this one. Thanks for watching. We'll see you next time.